Hello. I have done some things in OBS to make the thing louder. Hopefully it is not too loud. Hopefully it does not clip. I was listening back to the YouTube videos and they were easy sag, right? I'm just fixing a little compiler bug that I had introduced with the new compound declaration handling. Whoops, it's not. And then we're going to work on some new code. What do I mean by ship beta? If you have to ask, you don't know. If you have to ask, you can't afford it. Okay, so okay. What? I typed the wrong thing there. You know what? Let's just do it this way. I don't like how much code this is turning into. I'm going to do this. Okay. We put this up here. And then we put this. And then we put here. There we go. That's what I wanted. 914. It's not called subex. What? Oh. It's called from. From. Shut up about the trial license. Jesus. Okay, so that works. Did not work before. Now we make sure that everything else works, including me putting an S on the end of the word thread. Was the weekend project further work on invaders? No. No, it is something new. We will pick up the invaders to do nice curlies in a few weeks or something. We are going to do a different thing. Invaders 2, no. No. Are we squarifying? Yes. Yes, we will give a little intro. We will give a little info. Intro and info. All right, so assuming this works, I'm going to check it in. I'm going to give a little time for the build system to build the Linux and Mac OS binaries, and then we will ship the beta. Looks like a black screen, but that's just what level this... Oh, changelog is out of date. Mac OS gamepad fix. Good times. All right. Game works. Cool. It's a video game that we are making. Did I say goodbye to these comfy dense margins? I mean, we only just switched to Visual Studio 2019. So we tend to be about 4 years behind the newest version. And that's because the newest version is always the worst version. So the version of Visual Studio that we use is the oldest possible one that game consoles will allow us to use to build for their platform. Because they have tool chains that only support certain Visual Studios, right? Because they have to maintain those tool chains. So currently, last I checked, that was Visual Studio 2019 was the oldest that we could get away with. And I'm sorry, Microsoft, but everything that I said is 100% the honest truth. We stopped upgrading to newest Visual Studio probably sometime around Visual Studio 2006. It broke syntax highlighting, debugging, building, installed for minutes at a time. I am completely unsurprised. I am completely Look how surprised I am right now. Look how surprised I am. Let's make a release compiler, by the way. We haven't made one of those in a while. Why is my CPU fan still going? Oh, anti-malware. Okay. Okay, great. I'm sure glad that's happening. No, wrong. There we go. All right, so yeah. So I already, oh no, I didn't bump the version number and the dates. So 63. Bump the version number for the next beta. And as soon as all the build machines compile that, assuming they do, we can ship. Any random questions and answers while we wait for the frickin' build servers? Didn't like that. Frickin' Linux build, dude. What the actual fuck is happening? I might have to debug on Linux, which I don't want to do because the people cannot see. People cannot see the Linux bugs. 2 pumps or 3 pumps. I mean, I'm doing 3 lately and having a good time with it. Okay, I have an Ubuntu situation on the Razer. Oh fuck, that's the wrong thing. Maybe I don't. Maybe I have to get a totally different laptop. Thanks for the macOS gamepad fix. Well, we are trying to ship that officially to people, but I can't do it if the frickin' Linux build never builds. Frickin' Linux Torvalds. Frickin' Linux Torvalds. Do I think it's worth chasing review scores by including easy difficulty settings? No, nobody cares about what review scores by that amount. I mean, it probably matters if you're like 98 versus 68, but a couple points isn't going to matter. Nobody pays attention to video game reviews anymore. It's all just streamers and forums, word of mouth. So instead of including easy difficulty settings, include things that streamers or fans on forums would like if you're chasing audience. How hyped am I for Apple's WWDC? I mean, I remember the days when Steve Jobs would say, hey, we've got one more thing. Those were pretty cool. And then maybe the 1 or 2 after Tim Apple took over were kind of nice to watch, but like there hasn't been an Apple presentation in a long time. You know? Still going here. I think because this happens early in the build process and then the servers are still occupied doing debug build testing of these, which takes longer because debug build runs slower, right? So it may be a bit before they get to this one. In the meantime, I'm going to get my other laptop back out, which I just put away. Okay. Instead of doing it on a Windows laptop in WSL, I'm going to do it on a legit Linux Torvalds brand laptop made by Dell. Made by Steve Dell. And you can't see that, unfortunately. So I'm going to try to figure it out fast. Unfortunately, I haven't updated the compiler on the Linux Dell laptop in probably 18 years. Hey, look, you know it's a Linux Torvalds laptop because it boots and the first thing you see are errors and really tiny text on the console. I mean, am I wrong? All right. Am I wrong is my question for you. Okay, have I actually used this at this apartment? Yes, it's connected to the Wi-Fi. Okay, that's good. How do I get terminal? Here we go. Here we go. Update. We're updating the compiler. If I have Chrome on that machine, remote desktop works well enough. How do I do it? Do I have Chrome on this machine? No, I've been using Firefox. Does Chrome itself do remote desktop now? Is that how crazy web browsers are now? Are they reassuring errors? No, they're about like ACPI not working or something with an extension. Oh. Updated software is available for this computer. No, we're not going to do that. Okay, so I haven't updated this since before Raphael updated LLVM. So it's pulling down LLVM, and you know that that's like the size of half the internet. The reason it's called LLVM is it's European, right? It's European acronym. It's like how NATO is OTAN. It's the volume, that's the V. It's the volume of a large language model is why it's called LLVM, right? It's large language volume du modèle. And it just means that it's 500 terabytes that you have to download in order to do anything. It's still going. It's still, I'm not lying, by the way. We're still getting LLVM. I don't know if you could see that, but I'm sure you've got enough resolution to see that these file names are the same down to like 5 levels of directory, which is the LLVM files. I just ate before the stream, otherwise I would do some chai right now. I was getting a hankering for some chai, and then I'm like, let me just wait a little bit. Okay, Linux is just not happy. I don't know what its problem is. Let me go into high security mode for a second and check my email. I think it's the same. Uncompilable struct 1. Yeah, that's the same problem. You know, let me just, I just finished getting, wait, CMake is not installed? How did I build this before? Did it stop? Okay, for some reason, CMake used to run fine on this machine. I haven't changed anything. It's been turned off, but now it's on and I try to run CMake. I'm running the same command out of my history and it says gmake : snap CMake 1082 bin CMake no such file or directory. I don't know, it ate itself somehow. I don't know what to do besides reinstall. Oh, pending update of Snap Store. Close the app to avoid disruptions. Oh, it's just auto-updating me and things don't work, I guess? I don't know. I don't know. Oh, that's the store, though. That doesn't have much to do with the command line. We're just going to look for updates and see if that fixes anything. There's 2 different icons for software updates. Complete generic Linux kernel and headers. GNOME XML library. Secure sockets layer toolkit. Ubuntu base. It just wants to update so many things. I'm just going to let it do this. And, you know, if it renders this laptop unusable, we'll just reinstall later. Okay. So here's the thing. It's failing on one particular thing. So I'm just going to, and it's asserting that there's a specific error message happening. And I'm going to make a note to myself to investigate. But I don't think this should block the beta. So what I'm going to do is I'm going to come back out. I'm going to go, whoops. It's this one. But we are getting a different error on Mac OS and Linux. And my Linux machine will not let me work. I mean, here's the thing. It used to be if you hadn't used your Linux machine in 3 months and you turned it on, it would work fine. Like that was the thing, that it was reliable in that way. And now they fucking ruined even that. Like you turn it on and it's like, I don't know why things don't work. What is today? 12 May? All right. Let's just make sure that compiles. Mark a test as broken so as we can ship the beta. Beta blockers. Chris Latner is a smart guy. I mean, I've met him before. He's like a nice guy-ish, or I don't know. He's a reasonable person to have a conversation with. But I disagree with him enough about fundamental things like how to program that I couldn't really have a programming discussion with him. So, I don't know, man. Okay. I said install the updates and it says waiting for unattended -upger to exit, and it's just sitting there hanging now. Waiting for unattended upger to exit. I don't know what the fuck that means. How does anybody take any of this seriously? It's so bad. I mean, Windows is bad. But it's like Linux is getting bad faster than Windows is getting bad even. Like I don't understand what anybody thinks they're doing. Like this machine worked totally fine last time I used it. I turn it on, now it doesn't work. And then it prompts me to install upgrades, so I'm like, sure, and now it can't even do that. So like, I think it's bricked. I mean, I could try cold booting it and updating it again, but why would that matter? Because it was a cold boot. I think it's bricked. All right, we're going to try cold booting it. Oh, wait. It just stopped waiting for unattended upger and started installing. Okay. That was just like 5 minutes or something. All right. How are we doing here? Okay, still no reply to this. Lack of feedback during slow commands, yeah. This is even a GUI program doing the update, and there's still lack of feedback. And I bet it's actually a console program running in a pipe, and the GUI program is just like drawing some text, right? It's like, ugh. Ugh. Still waiting. Still waiting. The things that need attention are not being attended to. I know. It's true across all of these operating systems. Again, I think, again, it's because, I mean, it used to be all the smart people go into Wall Street. Now all the smart people go to Google and get paid $4 million a year so that neural networks can show people ads. It's like, okay, great, thanks. Neural networks will not be able to show people ads if these operating systems degrade so far that they don't fucking work anymore. Well, they're still going. Maybe that's a good sign. Or maybe I need to bump the fucking build because it doesn't update on the tests file. All right, I am feeling the chai latte, so while we're waiting, I'm going to make that happen. Here we go. Round one. Fight. Didn't go. Fight. It has a stupid touch button, so of course you can't push it consistently. If the server is mysteriously down, I have not been keeping up on how to start it, etc. So we might not be able to deliver value to the people tonight. That's going to piss me off. All right, guys. I have a question for Twitch chat. I have not played the new Legend of Link game. Of course, I didn't like the last one. I watched a streamer play it today. It just looked like a really boring game. It looked like the visuals look really nice for the system it's running on, especially. But like, it just looked like one of these games where it tells you what to do and then you go do it, and all the NPCs make baby noises when they talk. Like, as far as like, it just looks really boring. So the question is it actually good? Or is it just super boring? Yeah, like literally all the dialogue seemed like it was written for a baby as well. And I looked on Metacritic and it got 96 Metacritic. People want to be babied, maybe. Computer needs to restart to finish installing updates. If I didn't like Breath of the Wild, I won't like this. Yeah, well. I mean, the things that annoyed me about the first one was the combat wasn't interesting. The puzzle dungeons were not good. And you just sort of walk around and do nothing. And actually, counter to everybody's understanding, I thought there was an incredible lack of polish in the beginning of the game, because all sorts of things that I tried to do just naturally as a player, like, it just resulted in, you know, bugs or omissions in the gameplay code. Like, I remember trying to climb down the thing, climb down the wall in the beginning or whatever, and it just mysteriously was killing me. And I had no idea that that was because I was not done with the tutorial, right? It just kept dropping me off the wall and killing me. .96 on Metacritic just means it's easy and short. I don't know. It seems like it's a very, very long game. Okay, CMake still doesn't work. Now here's the thing though. I can run the CMake command and that works fine. If I run it without the application passwords and keys has closed unexpectedly. So that I'm gonna have to reinstall this fucking machine. So I run CMake, that exists, that's fine. It's just when I try to build the game, it can't find something about, I don't know. I'm going to try rerunning our init script that Raphael wrote. That worked. Okay, there's like something in the init script that sets up CMake that has changed, but okay, we're good now. Pizza Tower good? I didn't like it. I think Pizza Tower is very close to a good game. Which games did I enjoy? I liked the What If Zelda Was a Necrodancer game a little bit. I mean, it was a little bit easy and flat, but I still liked it. It's a game about exploration, that's it. Yeah, but exploring matters only if there's interesting things, right? So I was watching a streamer play, and he would go and he would like dig up a rock, and it's like a little baby plant demon would said, "Woohoo, you found me," and gave him a boo-boo seed. And he got boo-boo seed number 3 out of 7,000. And it's like, okay. I mean, the 7,000 is not literal. I don't know out of how many, but it sure seemed like about 7,000. Okay, so now we're having a problem. We're having some kind of C++ compiler problem with intrinsics. TZ count U32 target specific option mismatch. Inlining failed in call to always inline. So there's something in the header file. It's TZ count U32. It's marked always inline. It's why are we using GCC headers? What the fuck? Does Clang like use GCC headers for intrinsics? Did we somehow switch to GCC in Linux? I don't know. I'm ready to give up. Hey, we could ship though. All right. So, update my pupdate. Boom. Boom. How long did that take? It's too long. 4 minutes. Wait, did I not see this somehow? Because I checked several times over the past 6 minutes. I thought, oh, Jesus. All right. All right, round 1. Now we put the chai squirts. 1, 2. I'm going to try only 2 because I want to know if the frothiness is about how much chai juice. All right. This is 1063. Yep. All right, guys, I have to go into high security mode for a minute. And we've got to upload the thing. That might eat all your bandwidth on your internet. We'll see what happens. Streaming probably doesn't help this. It says 2 minutes. We'll see. Overly sweet. This one isn't super sweet, and it's spicy instead. Yeah, one other seed thing that I saw was there was a cube with one corner missing, and the corner was sitting right there next to the cube. And you had to just rotate it and put it on the cube. And then the little baby plant demon was like, "Whoa, you found me, I'm a baby, and so are you." And then you get the seed. This is the chai that I use. It is Maya chai, Devi style, which is spicy. Did I feel a sense of surprise and delight? Well, I didn't finish the cube. I was watching a streamer do it. It's not dried leaves. No, this is concentrated chai juice. It's his essence of truth and beauty distilled into a liquid. What happens if I drink it directly from that bottle? Probably I explode. Okay, while this is still finishing, I will compose the email to the beta people. Why fucking... Please do not send emails directly to me. They will get lost. Fucking, how can I not? All right. Okay, so we're going to compose to, oh, I can't send from Gmail anymore. I forgot. Copyright claim. What the fuck? So we were browsing for music on a website. I uploaded this thing to YouTube. The next situation in the invaders, and we were browsing little things, and it copyright struck me for like a 4-second thing from the web page. Yeah. Okay. Okay, what am I doing? I am trying to send the frickin' beta emails, which is hard now. I can't just do it. I want my chai latte. All right, here we go. It is more frothy on top. So I feel, I mean, look at this. Look at that. I feel like when I put more chai juice in, it is less frothy, which is a little bit sad. But we're going to have to A/B test that a couple times. You can't just form a theory of how the universe works. All right, so I have to go to email marketing tools, barf, but that's what this website calls it. Edit and send emails. New text-only email. We will put in the changelog. We will put in the text from the changelog. Okay. And then we put in the link, the hyperlink off the hyper internet, and that is done now. There we go. We send that. We're going to save beta 0.1.063. All right, we hit exit. Of course, it asks us if we want to save the content before exiting, even though we literally just saved it 3 seconds ago. Send. To all recipients. 500 people now is the number of people. Subject, new compiler beta. Send. Boom. All right. We can come out of high security mode now. Okay, before I have a cow, we have to check that this version is right. Okay. We have delivered value to the people. Yum, yum. Did I like the Super Mario Brothers movie? I did not see either one. I have really no interest in either movie. I'll enjoy the braid mechanic they patented. Oh, I bet. I bet. Seen anything decent recently? I mean, it depends on the definition of recently. Okay. I'm a little bit tired from the ordeal because I just hate dealing with system stuff like that. So I'm going to chill for a few more minutes. And then we'll start the thing.
Dr.
What? I don't care about that video. What are you doing? Oh, let's check in the... Start the change log for the new beta. If I don't do that, then if somebody else checks in changes, they'll conflict. Okay, now we're good. Should watch the 10-minute Zelda preview. I mean, I already watched a streamer play it. It just looks not my thing. Is there an up-to-date presentation? No, I don't do presentations anymore because people were copying me for their own languages all the time. I just stopped doing it. Sorry. I mean, I know people want that kind of information, but it was being abused. And so I don't do it anymore because people are assholes. How about more game design talks? You know, I kind of want to finish the current game before I do more game design talks. Okay, we might do another chai in a bit. They're so good. What were they copying exactly? Just whatever features I was doing. They would claim to have the same features, and of course they wouldn't be nearly as good, but they would claim they were better, right? Like, yeah, no, it's fucking stupid. Isn't that good for the ecosystem? No. No, it's not. Killing the people who are trying to innovate by trying to outcompete them before they can release their thing is a fucking asshole parasite move. That's a bottom feeder move. That's not good for the ecosystem unless it's an ecosystem of bottom feeders. All those people can fuck off. Bottom G move, exactly. Exactly. Any more lessons in the future? I don't know. I mean, I thought about doing a compiler one. We might do something like that. The 3D one was just like literally one day I was like, I really want to explain this thing. They never even cite you as an inspiration, even though they were followers and started their languages months after you started. And no, it's worse than that. It's worse than that. I have emails in my inbox from one of these people where I was like, they were like, hey man, I want to make a compiler for your language, but I want to change some stuff so it's not totally compatible. Is that okay? And I was like, look, it's not really a good thing to take somebody else's language and make a compiler for it that's deliberately incompatible. So why don't just make your own language, and you could be inspired by these features or whatever, but do what you want to do, right? And I guess so this person went and did that, but then in a passive aggressive way, again, where they're like trying to beat me to market on shit. And I'm like, just fuck off, dude. It's just such an asshole move. I have no respect for people who do that kind of tactic at all. Talk on learning and educational gaming content. Any plans to continue that? I mean, there are definitely questions about what games to make in the future. If Zach were still alive, he would have been probably making a puzzle game. I mean, unless he went off to do his own thing. But I would have, like, if he wanted it, given him just an entire project to be lead designer on and creative director. That would have been one project. And one project is, there's several things that I want to do that are gamey games. But there's one thing that I want to do that's an educational game, and I think it would be okay for someone else to be project lead of that. I mean, I would sort of be like executive project lead or something, where I'm not really totally doing it day to day. But we need to have enough money to do that, basically. And we're broke right now, because that's what happens when you go 8 years at $3 million a year not shipping games. But after we make some more money from these next couple games, maybe we could do that. And then, like, there's a very specific educational-ish game that I want to make. Zach Barth died? No, different Zach. 3 million a year. Yeah, no, the burn rate of my company is like, it's close to $3.5 million a year. Everybody wants to buy pizzas. I don't know what to tell you. And you have to pay people enough pizzas. And it's a lot of pizzas. You know, some of those pizzas are deep dish. It's like a whole thing. Some of them have to have the cheese crust, you know, where the cheese is inside the crust. Could have been sitting on a beach money. Oh yeah. Now, if I had gotten out of the games industry after The Witness, be a different situation. Which Zach? The Zach who's no longer with us, unfortunately. Should hire John Carmack. John Carmack wants too many pizzas for me, I'm sure. I mean, he wouldn't. He's busy on his own thing. How many people are employed for $3 million a year? Like 15. Running a company is way more expensive than people think. Yeah, especially if it's a software company. Very expensive. No, we do have a physical office, but that's not, it's a small percentage of the money. Almost 100% of company expenses is just salaries to people. Which is why it's so hilarious, all the people on Twitter going like, game companies are not fair and they don't pay the people. And it's like, you guys have no idea how much game companies pay out in salary to people. It's a lot. It's a lot. All right. Let's get ready. Should I? I'm tempted to split the stream. Maybe not. I don't know. Maybe I'll just change the title. Let's change the title. Whatever you do, don't split the streams. Okay. Let's introduce what is this weekend's weekend project. For a long time, okay, we have in our examples, we have this codec view program, codex, not codec, codex view program, right? Where you can browse files that contain statistics about your program. And, you know, we've shown this before, but you can see like what metric do you want to view and all this stuff. And this is all great. The visualization right now is basically one little rectangle per function. And we just color it and size the height according to different things. That is helpful sometimes. Like if what you literally want to do is say, I don't know, who performs heap allocations, right? And that's all you want to see, right? Wow, that's a lot of heap allocations. You're going to have to do something about that. You know, for other things, for other forms of program understanding, you might want to see more of a hierarchical relationship, right? This is not hierarchical. This is literally so I'm realizing it might not be that obvious what this is. So this is essentially one long row, and it starts here and it goes to the end and then continues. So like here it's by size is the sorting metric. It's secondary. It's by module by size actually. So it starts over at some point in every new module, right? So here the size is 1,000, and as I go right, it goes down, and it's 132 because these are all frickin' polymorphs of the same function, you know. So that's what this is, and that's one way of viewing your program that might be useful sometimes. But another thing is hierarchical, right? So let me show you, for example. Some of you guys might have used one of these programs. I'm actually looking for screenshots of the, yeah. So this, if you guys have seen this thing, right? So this is a program that, let me zoom in on the web page, Holio. I mean, the Phong shading is really bad and fake, but you know, this is a program, you can actually download it, where you point it at part of your disk or your whole disk, and it goes through the subdirectories, and the area of the rectangle is the size of the file, which makes it really easy if you want to say, like, what are the big files on my disk, right? This makes it really easy to find the big files, and then, you know, you can color these by extension or maybe other parameters, right? WizTree is better. That WizTree sounds like something that happens when you're in the forest and you drank too much water, but let's try it. Anyway, so this is a useful way of displaying things that are hierarchical, which is what our program is, right? And you would kind of like to know, oh, which modules are big, which modules are small, right, etc. And so we want to build a version of that that's for browsing code. But if we're going to do that, we might as well make that be like a getRect widget so that other people could use it, right? So we're going to make a getRect widget that's a tree map viewer. WizTree is WinDirStat. That's 100 times faster. Let's try WizT. WizTree, download. I have to donate. Let's try it. I mean, WinDirStat is really slow. That's the thing. All right, so let's say I want to go to the compiler and select that. Boom, there we go. Okay, that was definitely faster. But you see what's going on here, right? Although I don't quite understand. Okay, so they're kind of, I see. So they've got like a title bar on each one of these, which is interesting. And so this is actually a folder path. How do they decide? Okay, so this is everything in SEP. I see. This is pretty interesting for folders like this, right? Okay. I don't know if I like it. I think I like the vanilla everything in a rectangle better. Like, this is just more confusing and annoying to me, actually. What's the point of 2D visualization? Because it's easier to compare areas of things. If you put everything in 1D and you just have some insanely long line segment, it's maybe not good for detecting patterns. And it's not good for using the real estate of your screen, right? This is how it came up. I didn't do anything to make it broken up like this. What if I do that? Okay, no, it's still broken up. What if I just... On slash, it shows a lot of subdirs. I don't know why they did this. This is a little bit annoying to me. Although I guess this is it. Never mind. This is equivalent to what we want actually. Because without the titles, yeah, you can see how this makes more, in principle, more use of your brain's pattern matching faculties than if it were all packed in a line. Now that said, if you had some more interesting way to color each rectangle, that might be interesting, right? Like what are these? These are executable. Red is executable, so that's worth knowing. So you can just sort of glance and say, all right, well, then there's that much executable. Like here's a bunch of files of approximately the same size. Oh, look, it's Visual Studio. Dude, these are pre-compiled headers from Visual Studio. There's 67 megabytes a piece. This is how much of the entire project, including all the executables, etc., is pre-compiled headers. Why do they all use weird gradients? Because it just makes it a little bit easier to understand the objects. We'll probably try not to use those initially, but who knows? Yeah, it's easier to read the individual shapes. Am I going to make it to display module size or making another view for the heap allocation, etc.? Well, the initial use of it will be for program size, or, I mean, realistically, you know how in that, in codex view, you could pick whatever the metric is that you want to view. So we could regenerate a tree map for any metric, right? So like code quality, right, where smaller is better or something, right? That could be a thing that you see here. Now that said, it's a little bit hard to know how to color the squares to make them more legible if size is code quality, right? So we're going to have to figure that out. Like maybe you could imagine it's like colored by the number of parameters or something, right? Or by the size of the function. I don't know. I mean, the thing is, size of code maps pretty straightforwardly to size of rectangle. Like, it's not hard for your brain to understand that correlation. So maybe it's always best just to leave size as size, and then maybe code quality as color. And then you look for the rotten rectangles. Yeah, I don't know. Are we making a file manager? No. Well, here's the thing. We need some hierarchical data to test on when we start making the widget. Okay? And what is that going to look like? Well, I mean, we might just pick a subfolder on the machine and run this on it, right? Because we want some frickin' data. Okay. Size might be assigned to the most important data. Yeah, maybe. I mean, we'll play around with that. We'll play around with that. We're not going to get very far tonight just because it's 9 p.m. and I'm a little tired. Anyway, this is the idea of the kind of thing that we're trying to make, but we want to make it so that, you know, people can instantiate this for whatever they want. And then we can also use it. Okay. So, should run it on the LVM source. Yuck. I mean, okay. Actually, I could think of two ways to do this. One way is as a getRect widget. Another way is to say, this is like the start of a visualization library that has a bunch of different visualizers in it that are independent of a UI system like getRect. That might be more useful for people, right? I feel like that might be better. Because then you could use it even if you're not using getRect or whatever. Yeah, I think I like that. So we will do this just as a standalone program to start. It might be annoying to do some of the UI stuff without a getRect situation, but it is what it is. I've got a stuffy nose all of a sudden. All right, so my goal for tonight is just to get started and get as far as we can, and then when we wake up tomorrow, we'll see. We'll see where we're at, and we'll have a good jumping off point. All right? Okay, so what do we want to do? Obviously, we want a program that opens a window. That's not going to be part of the library, but we need it to do a thing. We'll just copy the simp example, probably. And we'll use simp to draw, although in the final visualization, you'll be able to override that and use whatever. We're going to display hierarchical data, so we're going to need a data structure that stores the hierarchy. And we're going to encourage you to store this as an array because that's what's fast, not a freaking tree. Now, well, we'll see. We'll see how that evolves. It might be easiest just to poop nodes all over the place like a computer science professor and then deal with that later. Now, We're going to want sample data to run it on, like I said, which means we will use, I mean, we could just type some fake numbers, but it's probably better just to get actual directory file data. And then, wow, my nose, I might be having a milk reaction. We need to run the tree map algorithm, of course, which we'll explain as we do it. It's pretty simple. Like, I read the paper, which you can read, and like literally the paper really should be a couple paragraphs, but it's like padded out to the length of a computer science paper because there's one idea in it, right? And the idea is, well, we try to keep things square by having an if statement. So we're gonna, okay, there's sort of a basic question about this data structure and how do you add things to the data structure. Because it's going to be like all the data object, like the files or the functions in the program or whatever, are leaves of the thing, right? And of course, this tree map, the way the visualization works is it's hierarchical. So you want to add up all the leaves till you get to the root, right? Yeah, I guess that's fine. And we could have the base thing just recompute from leaves. I mean, you can do a standard recursive computer science professor, you know, depth first visitation of the tree. And then you just add on the way up, right? You like, what do they call that? You add in post order or whatever the hell, right? Nobody cares about those names for things. And yeah, okay. Okay, so we're just going to start doing this. We're going to put it in examples. We're going to say tree map. And we're going to copy the simp example. Is there a data file? We might use this font. We're going to see. We might use these, so we're just going to copy them over and remove them later. Okay, examples, tree map, and then we'll SVN add this. Okay. Let's just say build. Build. All right. Because this is going to have a little bit of configuration, like are you using simp, are you using whatever, we'll have a build, and then we'll have there. All right. Oh. We don't want it to be called build. So we're going to say run compiler set Why is Emacs doing this to me lately? Compiler set build options DC name equals tree map. All right. Oh. Okay, tree map. What a cool programming language. Okay, it says simp. That's fine. That's fine. Okay. We're going to have a tree map data structure. And there's going to be two parallel things, right? Because there's like, the whole point of the squarification of the tree map is that it adapts the aspect ratio, right, of the little squares to be as square as possible. And what that means is you could have the same source data, like say you viewed your file system, right? And now you're resizing the window and you want to actually repack those squares each time the window resizes. You don't want to go scan the entire file system and read all the files every time. That's a very Microsoft thing to do, but you don't want to do that, right? You just want to repack all of the tree map nodes every time you resize, right? And so we want to store those in two different places. Okay, so did I add this? Yes. Okay, so we're going to have our data structure here. We're going to have a display node. What am I doing? Okay, and then we're going to have a tree map display, which is going to be nodes is an array of display node. Tree map is a tree map, all right? Tree map is going to be a struct that says, this just has like nodes. All right, and a tree map node is going to be a struct that's got a size, and that's all we're going to do right now. Because color and everything, you know, actually we probably want like a name associated with it. That's at least common to both of the cases of a like a file system. Every node's got a name. You know, in your program, every node's got a name. It's like the function or whatever, right? So that's fine. And the display node, okay, what is it going to have? It's going to have a color, which is a vector 4. It's going to have the index. Tree map node index is going to be S32. Actually, S6. Fuck it. S64. Big tree map. We've got big data. And then I don't know what else. You know, you could imagine some other data, but that's fine. Oh, and the tree map nodes. Okay, here's the thing. we need to store the hierarchicalness in some way. Now, the virgin computer science student way to do it is to have an array of children on each node, right? Because you're going top down. And we may just do that. But actually, right, all you really need is a parent index on each node. And if you're going bottom up, that's kind of all you need, right? So if you imagine that you store the nodes from leaves to root, so you just save in all your leaves, and then you go and you go and you go from left to right, you just iterate left to right and add the size to the parent node. Although you still have to know who's a leaf and who's not, because you have to know who to zero at the start of this thing. Also, I think in both of these cases, we want to explicitly construct the parent nodes at some time before we do this like size computation post pass, because you just do. You might want to name them certain ways. You might want to, I don't know, store metadata about them. Is this my normal process? Yes. This is approximately what I do every time I sit down to program. No serious programmer makes flowcharts or diagrams of classes. They might teach you that in school. It's a waste of time. I mean, it might be helpful as a learning tool, like when you're first figuring this stuff out. But once you know how to program, it's a waste of time. Normal process includes ice cream. That's a good point. Instead of doing more chai, we might do some ice cream. That's true. Does the order of the structs have implications on performance? No. Oh, you mean the members? I mean, we are approximately the same as C in terms of struct packing. So if you know how C goes, we're about the same because we have no problem with what C does right now. All right, so this is the thing is I don't just want to do the naive frickin' node ass situation. I feel like when you build a tree, you know the difference between a leaf and a non-leaf. Right? All right, we're just gonna do this. We're just gonna be virgin computer science student about it. Because once we get it working, we'll have a better, like, it's a good exercise to sit down and say, how do I be efficient about this and stuff? But like, if you don't immediately know, like I know how to be efficient about it, but it might also cause a lot of inconvenience that I don't want to suffer, right? And so then you say, well, let's just see what our usage is going to be, right? And then we'll streamline. So we're going to have an add node. You know what? This is just going to be a thing. That's going to be a thing. Oops. So we're going to add a node to a tree map, and we're going to return a tree map node. And do we... No. We want to set the index. All All right, node.index is index. Let's do this. We could make an accessor that's lower leveled, or one that doesn't do the name if we want. So this is obviously silly. And we're going to return the node. If you want to set the size or whatever, just poke it. It's fine. All right. So we do that. Oh, we want to say the parent, right? Okay. So, we'll make a root node on the tree map. All right. That's all fine. We're going to store index of the parent rather than the pointer to the parent. Why is that? Because we're going to have two parallel structures, remember, one for the display. And the display nodes are going to be in the same order and the same count as the actual tree map nodes. Okay? And if you just have the index here, you could use the index in both arrays. Whereas if you store the pointer to the parent, you have to go dereference the parent and get the parent's index. And that's annoying for cache locality reasons. Here, let's also just have corner as a vector 2 in screen coordinates and size as a vector 2. Right, okay. So we're going to have some function that updates that. I mean, we could use getRectRects, but we don't want to use getRect. Okay, so we're going to add the node. Okay, init. Oh, also, if you don't store pointers into the array, you don't have to have pointer stability, right? Which is why we can array add these. And these could move around as we reallocate the array, and we don't care because we're not taking pointers to them, right? So root, no, I don't know. I mean, should we set the parent to -1? I don't know. We'll do that for now. We might undo that later if, yeah. Now the thing is, do we really want to do this? I'm having a second thought about this because yeah, you know what? Because you want to name the root and all that. Like if it's the root of your, like if somebody picks a file or a folder and says, what's that? You want to name it that subfolder. And so here's what we're going to do instead. And we'll have less code, which is great. We're going to say, you add the root if we have no nodes. Let's just do this. If you have no nodes, assert parent is null, right? Else assert parent is not null. You can only add one root, i.e. Oh, you know what? I lied. I lied about the pointer stability. Because we're literally returning. I mean, we didn't really lie about it, except we did because we're having people pass in the parent node by pointer. Okay, this is bad. Should I use like a bucket array for now? See, already I'm conflicted. We have two options at least. We could use a data structure that provides pointer stability to store these, or we could say you don't do things by pointer. We're going to return you the index, right? But if we do that, we have to give you like frickin' getter setters to set the thing, and that is not really my style. You know what I'm saying? You know what I'm saying. Let's try the pointer stable array. We might regret this. So we're going to use bucket array. Like, it's kind of subjective what these should be, but it's fine. Bucket array of tree map node, a lot, like 1,024 per bucket, right? Okay. This is bucket array of display nodes. Actually, I'm not sure. I'm not sure that we need that. Let's just leave that for now. Because this here, we're providing more of an API to people, whereas here it's like, you know. Okay, so now, what is it called? Is it just add? I called it bucket array add for some reason. Do we have? We literally don't. Oh, it's called find and occupy empty slot. All right, so the thing that I don't necessarily like about the bucket array is we have a locator now, right? Which is, I mean, not that bad. It's just two integers. Yeah, it's fine. See, this is going to be slightly annoying no matter what. I just said all this stuff about storing parent index, but if we do a locator, we'll probably just store the pointer. I'm starting to like, see, these are the things. It seems like I'm hesitating over relatively trivial things, but this has consequences down the line in what we end up with, right? We want this to be a very fast system. Yeah, let's just be dumb for now, because I'm thinking about it for display purposes. We definitely want to be able to go from root toward leaves, which means we want a children array on the node and all this stuff. All right. So we're going to be totally virgin computer science student about all this, and we might regret it. All right. Here we go. Now, instead of using we'll use the bucket array, it's fine. Okay, so tree map. All right, we don't set node.index, right? So we're going to do this. The node and the locator. Tree map dot nodes. Whoops. I assume initialize is true. All right. So we do this. We say node dot locator equals locator. Is that what it's called? Bucket locator. Okay, so all right. Node name, node parent, node locator. If parent, array add parent.children, comma, node. All right. So now we're maintaining this in both directions, and that's pretty good, right? Why? Emacs just started indenting things. Maybe it's something about the .emacs on this machine. All right. Oh, import bucket array. We want that. Okay. Oh, that's yay. Okay, I haven't used bucket array in a while. Yeah, we have count. All right, cool. So, well, now we want some data in our nodes. And I think we're just going to hard code a directory traversal. Just for our machine here, right? And then maybe later we'll do something like pass a command line option. We'll just go in examples. So, all right. So here we're going to have, okay, we're still drawing simp. Get rid of the image test. Make sure okay. So maybe we make another file. We're going to call it, I don't know, file, right? Save that out. Make sure we still compile. Great. So what is this? This is going to have init tree map data. I don't know. Will folder is, like I said, this is going to be hard coded. Okay, and then I haven't done visit files in a while. Okay, visit files, folder, true, user data. Well, okay, we're going to go return a tree map, right? Return tree map. So that's going to be our user data. Proc is going to be visit. Let's call it visit. Visit files true, visit directories true. Because we want to visit the directories to make those nodes, right? Okay, so now we're going to go visit is going to be a function that takes info as a file, visit info, user tree map is a tree map, all right? And file visit info if is directory, we're going to say it dot full name, else okay. We need to call init tree map data from startup somewhere, right? Just going to do this before our main loop here. Okay, it is not the right thing. It's info, people. Come on, get with the program. Info.name. Oh yeah, it's short name. Short name, full name. Okay, it didn't. We didn't print anything. Hopefully our log function prints things out. It doesn't. I think, does log by default not print shit? What? That can't be. What's going on? Oh, is it because we're doing something to detach from the console? What is going on? Disable runtime console. That's why we're not printing anything. There we go. File, 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 directory, file, file. See all this? See all this? This is our hierarchical data. Okay. Now, the problem is sort of that we have to reconstruct the hierarchy a little bit. Because the file visit info will go down into directories. But I don't think it tells us when we go like back up, right? We could always use the full name. and compare that against directory names. Yeah, let's just do this. I'm going to add a directory node. That'll be a function that we define in a second. Add file node, tree map, info.full name, info.short name. Do we get the size per chance? Mod time. Nope. So file mod time and size. All right, so we'll get that. All right. So there we go. So we need to find these functions. Add directory node. Tree map is a tree map and full name is a string. Okay, and then add file node. Tree map is a tree map. Full name, short name is a string. This should be a substring of this. Do I want to store the full name in the tree map, or do I want to store just the short name? I feel like if it's a file, short name, who knows? Because it's implied by where it is. It doesn't really matter because we'll go ahead and do full name, actually. So I'm not even going to pass short name. Okay. So here we go. We're going to say add node, tree map, full name, and parent. See, this is the part that we can't do yet. Unless file visit does all files before doing any directories, which may not, I don't remember how we did it. All those wasted bytes are crying now. I know. That's the kind of thing that we could tweak later, though. Would a basic BST with past size left, right? What is a BST? No, this is not a tree that's fundamentally binary. There can be a bazillion things in each level. So you can, of course, turn that into a binary tree, but then you need some kind of mapping from the binary to the non-binary tree, and that's just trash. There's no reason to do that. I don't know what the S stands for in BST. Bacon, sausage, and tomato. Okay. Search. Search? What is... I guess search just means to you it's sorted by some value in the nodes. Yeah. Okay, let's look at our file visit a little bit more. Okay. When we get a directory, we buffer it up. We call okay. What do we do? I wrote the original version of this, but I think it's been modified. Okay, if it's a directory, I'm looking right here by the cursor, we say this is either true or false. For us, it's going to be true. But we do this as soon as we see the directory. And then we add it. So yeah, we might do a directory and then another directory and then another directory and then the files inside the directory. So I could imagine wanting something different from that. For now, we're not going to worry about it. What was it called? Build tree map. File. All right. Also, we're going to del this image test because we don't need that. Boom. Okay, so here's what we're going to do. We're just going to add the node. And the parent let's just look at what this looks like for a second. All right. So yeah, we don't have slashes on the ends. That's great. So what we're going to do is we're going to have a directory table, which is going to be a hash table from string to pointer to tree map node. This is another reason why it's helpful to have the pointer, I guess. This is just table. What's her job? Tables. All right, so what we're going to do is we'll use the path stuff in string. So in here we have path decomp, right? Path base name extension. All right, so path base name is decomp full name. All right. No, path decomp, bro. Path decomp. Okay. So this gives us a slash there, which we don't necessarily want. Okay, so that's going to take the slashes off. And now we're going to say parent is find, table find. And I think yeah, we return a success value second, which I don't know why I did that, but okay. I kind of know why I did that, but all right. Directory table by the path. If found parent parent.name else log error parent whatever not found path. All right. Okay. And then parent equals, oh, actually, yeah. So it is quite possible that this is the first directory, in which case it's going to be the root. If this is the first time we got here, it's the root. Forget about it. All right. So if directory table.count is 0, it's the first time. Otherwise, etc. Right? Parent is going to be a pointer to a tree map node. All right. Leave the parent null. We're the root. It's fine. Okay. Otherwise, okay. Otherwise, we assign that. And now we go, what we've all been waiting for is to say add node, tree map. What did we call it? Just 2 arguments? No, string and parent, right. That was the whole point of this, is to get the parent, all right? So the string is full name parent, all right? Okay, we asserted in line 38, no, oh, this is the thing. We said visiting. Oh, because we never add. Okay, first of all, we literally never add. So here, now we want to go table add, directory, table, full name, node. All right. Still not going to solve our problem, but a necessary step. Okay. Path, parent, not found. Log adding whatever. So we should see that. Adding examples.build. Wait, what? Oh. Oh. We are not adding for this. Now, what we're going to do, because the file visit doesn't give you the initial directory. Maybe it should, but it doesn't right now. So we want to do this, which means we don't need any of this stuff. All right, because we're always going to have a root. But if we see, in Windows is case insensitive and whatever, so we want to make sure that this matches what file visit is going to. give us for subsequent things. Okay, anyway, root is add node tree map folder null, which is fine because the root's a special case anyway, so doing it above everything else I don't feel bad about. Directory table folder and let's just do this, because like I said, we might have to do something on that. Okay, directory table canonical root. Parent equals tree map node 0. Okay. So if we can't ever find, we'll child to the root. That'll actually make better behavior in case our problem is that this is not canonicalized, but we don't want to rely on that. Okay. Directory table canonical root. This is taking a long time just to do the file thing, but whatever. We're having fun. What was I doing? Right. Root. All right. Fodler. I'm a fodler for Bitcoin. Node sub 0 does not take this operator. Now let's just do this. It's just easier anyway. It's like explicitly the one that we made here. All right. Well, okay. At the end of this, let's just print tree map is whatever. I mean, we're not going to see a ton of info, but it's got 82 nodes, and this is the bucket array. So we're not adding file nodes. So there's 82 subfolders, right? Because we've got Clang examples, Objective-C, Metal Bin, Clang 9, include, yeah, okay. Oh wait, no, we're getting parent not found. Sorry, I was looking and it wasn't in red. Wait, why are we getting parent not found? Let's go to the beginning. Parent 0 initialized any. Okay, that's not good. So literally, that's a null pointer going in, I think. Although I'm a little not thrilled about printing 0 initialized any in that case. Add file node, add directory node. Okay, so let's just print out, just so that we're not super confused. We're going to print out the full name that we get, right? Okay. So we get this. We're finding the parent. Wait. Oh, we're not setting the name on the node, guys. We're not setting, wait, are we not? When we say add node, we're not setting, no, we are. We are setting the name. What is going on? Oh, parent doesn't exist. How are we able to, why is that not crash? All right. Lol. I don't understand computers. Yeah, I actually don't know why that didn't crash. That was like the code knowing that that was null and like doing something. I'm not sure about that. Okay. Anyway, we're not going to worry about that right this second. Okay, so we got our full name, we got our parent name, we got our base name. There we go, there we go, there we go. Okay. We start getting not founds down here. Is this, so now here's the thing, guys. I've never tried to do this with the file visit. There could be bugs in file visit, right? Because usually I just use it in a more invisible way than this. Like it's saying beta key mailer not found. Oh, wait. Adding beta key mailer. That's not good. I feel like our table is screwing up. Let's just say maybe we're hitting like a table resize and getting confused. I don't feel like we should. That should not be an issue. But like after some point, we're literally never finding anything. Table count 25. This is pretty weird. Why are we stopping at 25? Okay, so let's down here. We're going to say print table dump for value key directory table key value. All right. What's up? What's up? Okay, our strings are all fucked, is what's happening. But I said copy string. Did somebody make copy string douchey? I'll be angry if somebody, no? We get Alex string. It's like literally the first 4 bytes or something. What is going on? Anyone have a suggestion about what is going on? So size min is 32. 32 times 0.7 is, I bet, about 25. Around. Because that would trigger a resize, right? What am I doing? This is not supposed to be a problem. Oh, you know what? Here's the thing. I'm not copying the, okay, right. The table doesn't copy the key. I was being douchey. Not not the other thing. Right? So gotta do that. That's all. Sorry. All right. Hey, look, they're not corrupted anymore. That's the fact that that took me more than 1 second to realize means that I'm pretty tired. Okay, so that's great. So now that we have all these, let's get rid of the table dump so we can see things again. So I don't see any errors, which means if we add the file nodes, we should find them all the time. So file node, same as directory node, kinda. All right, we're going to add a node. We're going to table add. We are going to want to tell the tree map that it's a leaf. Or maybe it knows that it's a leaf, right? Like, okay, so the easiest UI for people is if when you say add node, it puts it in an array of leaves, and then if you ever use it as a parent, it removes it from that, right? I think we'll do that. We'll do that. All right. In the tree map, we're going to say leaves is a hash table mapping a pointer to tree map node to a bool. All right. We're going to say table set leaves for node to true. All right. And then if parent, we're going to table set parent to false. All right. Okay. So for tree map.leaves, leaves, if value comma key, no, key dot name. Right, that's not hash table. I should alias it to I called it table like a long time ago, and yeah, I don't know. Okay, parent. Add file. Oh yeah, I pasted that because, okay, let's just not do any of this yet. Okay, so leaves. Okay, we don't have the examples folder. We don't have launcher box. These are all the folders for which we didn't add any files in, right? Now, we're going to add files, and then hopefully these folders would, etc. All right, here we go. We're going to want to do something with file, mod, time, and size. Let's actually do that. File, whatever, size, whatever. All right. So we're going to do the same thing here. This is very copy pasta. This root comment is no longer true. All right. We might factor that out at some point. Okay, and then node is going to be add node. Yes. And we do not add this to the directory table. We should not have anything that's a child of another file. And we're going to do that. Okay, now our leaves are files. See this? Leaves, 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 leaves. It's all the files. And later, when we actually start processing the tree map, we go upward. Okay, we're getting sizes for all these files. Look at these sizes. You know what that means? We can set that on the node now. All right. Node.size is cast float size. All right. Now, we're going to take a 5-minute brain break because we've just done our 2-hour Pomodoro. The next step will be to, we'll make a file. We'll just type it now. It won't compile yet, but we're going to say compute sizes. We might give this a different name later, but this is going to be in the tree map library, and it's just going to be like, okay, go from the roots and set all the sizes for the people. Could an empty directory become a leaf? Empty directories are leaves right now, yes. If we want to change that, we could have a function that says this is not a leaf or whatever. It doesn't really matter right now because an empty directory is going to contribute a size 0 to the hierarchy. Okay, any questions about what we have been doing so far before we go to the next part? Questions, questions. I was thinking, like, it's really cold in here, and my thermostat, well, at the apartment I'm renting, it's not mine, is like a little flaky connection, and it like wasn't going. It wasn't going. I'm looking for serious questions. I don't see them. What was the random 4 bytes issue? It was just the strings were getting freed. It's standard stupid issue. Okay, I've also closed my window tighter. Closed my window tighter. All right. Let's take a couple more minutes of brain break. Nobody has any questions, which leads me to believe that I should just quit programming on stream because nobody cares. All right, well, let's compute sizes. Here's what I think I'm going to do. We might want some flags on our tree map nodes. We're just going to have a flag that says leaf. Right? So we're going to be able to iterate over all these without, because there's this hash table, and it's like, okay, when it's time to compute the sizes, you could check every node's pointer by hashing the pointer. And like, that's just a little bit ass, right? So we're going to have this so we're going to make a guy a leaf whenever we make him. Clear out leaf from the parent. Okay. Now, when we say compute sizes, zero out sizes of non-leaves. All right, so for if the flags is not leaf, then it dot size is 0. All right. Pass 2. Here's the annoying part. We kind of just want to go from leaves to root, like I was saying. And because the API that we use when you add a node, because the API means you add an existing node as parent, there's no way to make it so that a leaf is before the parent node. And so, therefore, can I iterate by bucket array backwards? Dang it. All right. We'll do it this way. Pass 2, iterate from leaves, adding sizes to parents. Manual iteration of bucket array, since it's for expansion, does not currently handle reverse iteration. Sag. Okay, so we're going to go treemap.nodes.allBuckets, or no, yeah, I guess. All right, what is the, it goes over all buckets, yeah, okay, so for, okay, and then for whatever, wait, we could just do this in reverse. Am I smoking crack? This is trivial. Ugh, fucking Emacs. Like, all right. Wait, why wouldn't this? Hold on. Go over the buckets backwards. Is it just the index? That we don't like? If we're reversing, we're going to say this is array.count, else -1. Okay. If flags and reverse What is Emacs doing, dude? I don't even know. If we're in reverse, we're going to go -1. Otherwise, we're going to go +1. I guess. Okay. So we're just going to do this, I guess. For backwards, tree map.nodes, and if it.parent.size plus equals it.size. All right. I can't get the root. I guess we never did array subscript, or maybe we do. Hold on. Operator. We literally don't do subscript for bucket array, which we should do at some point. I don't want to do it right now. Root is tree map dot all buckets 0 dot data 0 root dot size. All right. How many mistakes did we make? Compile time. Oh, wait, what? I left the assert in there, guys. Smooth brain, all buckets. It's tree map dot nodes. Okay. We printed the leaves, but before that, oh my God, there's so many leaves. Before that, we should have printed the size. Tree map. Root size. Hey, look at that. That pretty much looks like the sizes of all the files. Okay. Here's what we could do, though. When we iterate the leaves, we could add a number either when we scan the files or when we scan the leaves after. But let's do it when we scan the file. All right. Double check size is going to be an int, and we're going to say clean up, remove this. When we get a file, we're going to say double check size plus equals size. Okay, we're going to not print this stuff at the end here. All right, we're going to say print double check size, whatever, double check size. This should match what we computed. It totally doesn't. Well, okay, so now it's like, do we debug this? Let's see what Windows says. (376929250). Well, the double check size is giving us the same answer as Bill Microsoft does. So now that's a 9-digit number. This is only an 8-digit number. So like we're not adding everything correctly. Okay, well, like I said, we can also do a post size. So we're going to go post size is an int. All right. Let's capitalize these. Right, so we can iterate over all the leaves, because maybe it's our leaf markings are wrong, right? Right. Or maybe just my recursive thing that I did. Maybe the backwards iteration is wrong. There's a quick and dirty thing we could do to figure that out. Okay, so if the post size comes out correct, then we can do the other thing, all right? So for everything in the leaves, if value post size, value is that hash table that says if we're a leaf. Although we don't need that hash table now that we have the flag. So we might delete that whole hash table. Oops, but for now we have it and we can check it. Post size plus equals key.size. Post size has got to be a float, actually. All right. Okay. I think some temporary file got written like literally between these times. I mean, I don't know. Our double check size is coming out the same every time, but our post size is not. Our post size is always slightly bigger. What? Oh, guys, floats cannot hold this precision of integer. Float 64s can, and you know what? We should just make the tree map be float 64. No reason not to. Hey, look, the numbers match now. The numbers match now. Why float and not integer for byte sizes? Because we are making generic code that would draw the sizes of anything, and sizes may not be integers. It could be the weight in grams of something. But we don't know. Okay. So these match. This still isn't right. Okay, so we're going to check the backwards iteration. Here's what we're going to do. We're going to do a forward iteration. This is disgusting. Copy. Array reserve. This actually isn't that disgusting, honestly. For this array add, copy it, and then we're just going to go for reverse. Should be copies. No, copy. We're going to reverse over copy, which is a flat array, if it.parent, it.parent.size plus equals it.size. Now I could think of a few, maybe we're not setting parent on folders, but I thought we were. I don't know. Okay, look. Now, root size, they're all the same. They're all correct. Okay? We can delete post size now. That's not necessary anymore. In fact, you know what's not necessary is this whole leaf table. We don't need it for now. Okay, so now we have two things. Root size and double check size, and they match. So that's great. Now, what I guess the only thing to do is figure out why the backwards iteration is brokeholio. I'm going to try this down here. So we're going to go just backwards over the thing. Let's just see what happens there. So we're hitting all the indices. Okay. Versus whatever. So we're going to print the node that we get, and we're also going to print copy sub it index, because those should match. If it's a correct backward iteration, then the order we visit the nodes here should match the order that we did when we manually reversed them here. They totally don't. Okay, wait. Index 0 here is BCBF 0480. Something tells me it's the first one. It literally is. Wait, what? O480 04D8. How? What? We're just not doing a... No, we are doing a reverse iteration, though, because the index is good. What is happening? Okay, let's see. Oh. I forgot this part. I think I can just do this, right? Just to give myself... Yeah. I just want a shorter name. Right? Cool. So then we could do all these. If reverse, all right. And if reverse, do that. Okay. Now it's the same number. Okay, so that means that here we don't have to do this crapholio that I did. Oops, hold on. So we're just going to go for tree map.nodes. That's what we wanted. There we go. Okay. And they match. You need to reverse the outer loop too. It was already reversed. If you look here, oh no, it's not reversed. Thank you. I thought that. I thought it in my brain and then didn't do it. So the only reason this worked is because our data is small enough that it fits in one bucket, because like the items per bucket by default is whatever we said. What did we say? 1,024, yeah. So we were all fitting in the first bucket, which was why that appeared to work. Okay, this seems like a good place to leave off. We have a GUI program. It also has a graphical user interface. And we have, we're reading a file system to gather hierarchical data. We're putting together that hierarchical data. Next step is to start drawing it graphically. And it seems like a good time to take a break and pick up in part 2 later over the weekend. What do you think? Questions on this? I know y'all have questions. All we've been making here is a hierarchical data structure that is somewhat generic so that it's retargetable to other things besides files, right? We're using files because that's an easy source of hierarchical data with sizes attached, right? The goal is not to make a disk space viewer. It's to make just a general tree map thing that we can then use on code. Make sure to like and subscribe. Are we visiting? We don't care about files. It's not about files. Why did I not make the tree map nodes polymorphic instead of using the float64? Because like genericism isn't free. It leads to more compile time and worse error messages, and you know, you have to think harder about using the thing. And so you shouldn't make everything generic for no reason. Like just because language features exist doesn't mean they should be used in all cases. And this is a problem. Like this is a problem across programming where people just overdo stuff. Like go look at boost.org if you want an example of that, or whatever. Is it boost.org? Boost.org. Oh yeah, baby. They no longer have the totally absurd example homepage, but last I checked it was on there somewhere. Anyway. How are we handling? It doesn't matter. This isn't about files. I don't care about symlinks. I don't care about anything. This isn't about files. Please don't ask me about files. Okay. Why flag leaves instead of checking children? That's a good point. The reason is because I just didn't think about it. The reason is the following. I decided early on in my thought process, which I didn't verbalize, that I was maybe going to flag leaves. And that was before I decided to store this explicit children array. You're right that now that we do this, there's no reason to flag leaves. Let's go ahead and simplify. We could bring this back later if we want. All right, but yeah, no, you're right. You're right. Okay, the only question is what happens if someone incrementally modifies the thing to remove children. Like if we ever remove a child and then make something into a leaf again, we need to make sure to zero its size. But then we would have to make sure to flag it as leaf as well, right? Right. If you don't zero the size, yeah, it's going to give you an incorrect result. All right. So, yeah, I mean, I think that's pretty much it. Yep. Easy clap. See, that's someone who is paying attention who asked that question. Would the C++ mgui lib be worth porting? We provide bindings for it, if you mean dear mgui. Why is bucket arrays? Because we wanted pointer stability, because we're returning pointers to nodes to the user, and we don't want them to move when we resize. You could okay, there's basically two different ways that you could provide pointer stability. The one that we did was to use bucket array or any data structure that gives you pointer stability. The other thing that you could do is like allocate every node separately and then just have the array be the array of addresses, right? That's less good for iteration because you've got a level of indirection. But it's not so bad if all the nodes are allocated, if you don't just use the heap, right, but all the nodes are allocated from like a pool or something, it's not that bad to do it that way. And you might consider that simpler. I was going back and forth in my head about which way to do it, and I decided to use the bucket array in part because it's exercising that data structure more. I was thinking like, oh, I haven't really, like I use them in the Sokoban game, but I just sort of set them up a long time ago and then we just don't think about them. So it's useful to use it in another context and then we can see if there's a problem like we did see. We were like, oh, we want to iterate over this backwards. It's not implemented. Why not? It seems easy, etc. Right? So, and by the way, definitely back when I did the videos about iteration, which was years ago now, I had backwards iteration as a feature, and some people said, you sure you want to do that? Like that sounds like a weird niche use case, but you actually want to iterate backwards all the time. Here's a perfect example of why you would want to iterate backwards, right? Like this was totally natural. I didn't force it. It's like, look, we're setting up this data structure and then the leaves are at the end. And if you iterate backwards, then you just get the right, like this is how simple this is. All right? Like everyone loves to talk, everyone in computer science school who's trying to indoctrinate you will tell you about how simple and beautiful like Lisp is or whatever, but like seriously, let's like this is the algorithm for refreshing the size of the tree map. Like what do you want, right? What's the basic idea behind bucket array? The idea is, okay, so the reason if you have a regular dynamic array, that has to be flat, right? When we write a dot dot array, this is like, if you use the horribly named vector in C++, the standard colon, STD, sexually transmitted disease, colon vector, it's a similar idea where you have a bunch of elements packed contiguously in memory. If you're out of memory for new elements and you want to add an element, you have to reallocate it somewhere else and copy all the items. All right? If you do that, then anyone who's holding a pointer to one of those items now has an invalid pointer. That's not good. And so, like I said, there's various ways that you could get around that. The way for bucket array is that it's actually a two-level structure. You have a bucket. Here it's 1024 tree map nodes. Each bucket is enough space for 1024 tree map nodes, and you allocate them in there. And then once you run out of memory for new guys, you just add another bucket, right? And so then there's a two-level thing. There's an array of buckets, and then there's each bucket. So it's a little bit slower to index, but not necessarily in a way that matters for most applications. And in return, you get pointer stability. Statically transmitted disease. Yeah. Don't you want to iterate backwards to delete elements of a list or something? Maybe. I mean, there are various reasons why you want to iterate backwards sometimes, right? This is a good place to leave off. Commit. Starting the tree map example. And so our tests are not, oh, we've got a no check-in. Oh yeah. Let's just comment this out for now. We might want to re-enable that. Also though, here, I'm a little bit up in the air about whether, see, I was starting to put all these into the build here, but I sort of feel now like it's fine if individual dudes who want to take dependencies do that, right? I don't know. Is this type of thing normally called a bucket array? I just made up that name. I'm sure it's not a very hard idea to come up with, so I'm sure other people have other names for the same thing. I just don't know what they call them. That said, there are, let's get rid of the double check size even. There are some slight differences in implementation. So for example, we keep an array of unfull buckets because because you can remove elements, right? And so after you've removed an element from a bucket, it's not full. And so next time somebody wants to allocate, instead of getting more memory, you could just get the first unfull bucket, right? And so we do that. And then, instead of a linked list of all the buckets, which you could imagine, we have an array of all the buckets. And then to index, we use this thing called bucket locator. And we probably should make a subscript operator, which we don't have. But those are all like, those are implementation details that aren't that big, right? The basic idea is just like, look, there's buckets, and each one has a fixed number of items. These aren't dynamically sized buckets. And then you fill them up in order. It's not a complicated idea. You guess bucket array only supports add remove from the end? No, it's from anywhere. Because when you add, we give you this bucket locator. The bucket locator tells you what bucket and then what slot in that bucket, right? And so when you say remove, you give it the locator, and we say that slot is no longer occupied, and etc. And we kind of waste an entire Boolean for each. This could be a flag. You would just have to do a little bit of flag math. Although I didn't want to have like a maximum, like, you know, you would have to have like U64s of items per bucket plus 63 divided by 64. Like, it just gets a little bit messier, and I didn't want to do that right now. So iterating requires O of max index, not O of number of elements. Yeah, in the worst case, because no, I guess that's true. Yeah. So if you were in a situation where you were adding a ton of elements and then removing most of them, like you're adding like 50 million elements, right? And then you're removing 49.8 million elements. Iteration would be pretty slow here, and this data structure would not be well tuned for that, because you would spend most of your time visiting unused slots, right? But that's always true. Like you can go insane if you try to anticipate everybody's use case and try to make something good for every single use case, because you can never do that. Like, it'll always end up being mediocre in some case, and then the code becomes complicated and people become scared of it. That's what happens to C++ standard libraries. So instead of doing that, we just say, look, this is pretty simple. Like this bucket array, it's 167 lines, counting all the blank lines as lines, right? It's very simple compared to a data structure that you would find anywhere in the C++ statically transmitted diseases, right? So I think that's massively preferable, because now you can look at this. If you wanted to use this as a baseline for your own thing that is more tuned toward being empty, you could actually just copy the file and delete some stuff and rearrange. Because it's simple enough, that becomes a feasible approach. Whereas, you know, if it's just like a giant gnarly mess, you just have to nuke it from orbit and start over. And I think that is less conducive to ongoing experimentation and participation and figuring things out. Yeah. Yeah, that's, by the way, that's a choice that I make a lot. That whole thing about, like, if you delete a ton, use a different data structure. So the hash table as well, if you remove an item from the hash table, it makes a little tombstone, but you can't, like, you know, you can't put something there until the hash table gets resized. So what happens, that one's actually not that bad, because, you know, you add a bunch of items from the table, you remove a bunch of items, and then you add some more. And as soon as you add enough to get over the limit, the next resize will get rid of all the tombstones, right? But this thing doesn't have that. You could imagine, how would you optimize this for holes? There's some basic stuff you could do that is not like algorithmically amazingly smart, but probably would help a lot. So for example, well, okay. So for example, when we're adding elements, we have this index where it's like, okay, everything to the left of this index we know is full, right? Because the normal operation is to go left to right and add things, and so this just goes up by 1, right? And then if you remove something, you just set this to the min of its current value and the index of the thing you removed, and that's where you start searching next time you add something, right? come to think of it, that's actually not the best behavior in some cases. Like you could find a pathological behavior where that was a bad thing to do. But anyway, so you could have a bound that's like the rightmost item that is non-zero and the leftmost item that's non-zero. And then you would at least for each bucket be iterating in between. And then if those ever met each other, like your count goes down to 0, those are equivalent statements, then you might remove that bucket from the buckets array and put it in unfull buckets, but not in all, but flag it. Like, I don't know, it just starts getting more complicated because this has to be an ordered remove. So the rest of the buckets have to be, you know, in order. And that would make you tempted to make it a linked list instead of an array, but maybe not, because an ordered remove becomes slow if the array is really long because you're copying all the array elements. But then a linked list is slow to navigate if the linked list is long, right? Except because you'd be navigating that to subscript. So these are all things that you would think about. And the thing is, if you're trying to make it, if you have the mission statement of generically speaking, we sort of want this to be fast for people who might be removing a lot of elements. It's like, okay, but it helps a lot more to have a very specific thing that you're working on that you have profiling data for. And then you can be like, oh no, for my data in this particular case, we want to do the following thing. Because some of these decisions depend on how often do you insert and remove relative to how often do you subscript the array, for example, right? And those are different for every program. And so, yeah, like what you would do in that case is design something for your needs. Jagged array. It's the Alanis Morissette array. Is that what it's called? Let's see. Jagged array, also known as a ragged array or irregular, is an array of arrays of which the member arrays can be different lengths. No, that's not what we're doing here. That's a different thing. A little bit. It's probably has similar reasons for existing, but our subarrays are the same length as each other. It's just they might have empty slots in the middle. Could mark empty buckets and skip them on iteration. Yeah, in fact, well, they're already de facto marked because the count goes down on the bucket. And so if it hits 0, you could just have a thing, right? So when we say find not, well, not for that. We actually don't. Right, so I guess the thing that we've been using that would apply to is this, right? The for loop expansion. Instead of doing this inner loop, you would just say, if the bucket's count is 0, continue, right? I just don't necessarily want to insert that line here because it's not going to be helpful most of the time, I think. And it'll cost something. I mean, although it's a predictable branch, so it doesn't cost that much, but it does cost, and it's a line of code. And if you're going into it cold, predictable branches are not predicted, right? If your instruction cache is cold. So just minimizing if statements is not that bad of an idea, which is why, for example, these are static ifs here. They don't cost anything. All right, any other questions? That was a good discussion, I felt like. Ay, ay, ay. On topic questions. On topic questions. How do you use it? What's it? Were you here for the stream that is still going where we used it? Is static if a thing in other languages? In some languages, yeah. Like even C++ has static if now. It's just got a really awkward syntax and a lot of limitations and landmines and foot guns. I just got here. Okay, well, if you want to watch the VOD, which will also be posted on YouTube later, the whole reason we're talking about this is because we used it for the thing that we were doing. Can you explain the general tactic to be fast when working with trees? The answer is don't work with trees. To be honest. You'll notice, so because we wanted to be pointer stable, we're returning nodes and stuff, right? But the nodes are stored in an array. And let's go back over here. Actually, no, let's go here, right? We're just iterating over the array linearly and then going backwards, right? And this would be even better. Well, no, it's fine because we're iterating linearly over memory. It's fine. That's what you want to do with trees if you can at all help it. This whole computer science thing about visit the left and then visit the right and all these things, like you do have to do that sometimes, but it's a problem. Computers don't like that. You can try to make that faster by storing, if you're likely to visit nodes in succession, you store them close to each other and then you get better cache locality out of it. This gives us maximum cache locality because we're iterating over things that are packed directly together 100% of the time, right? Now, if you were Mike Acton, you would store all the sizes in a totally separate array. And then you'd get more cache utilization ratio out of this. But we're not worried about that right now. It will be the license to the bucket array source file. I mean, it's just public domain. It's fine. If you used a binary tree instead of an array for the buckets, would it just turn into a many-leg tree? I don't know. That doesn't make sense to me. You would never do that because the whole point of the buckets is to minimize heap allocations. And as soon as you start talking about a binary tree, I guess you're talking about doing a lot more heap allocations to make the tree nodes, which is beside the point. So I would simply not do that. Does iterating backwards have the same cache locality as iterating forwards? Yes, it does. Especially, I mean, the data is just as contiguous, right? The question is just, is the processor good at noticing the backwards access pattern and fetching things into cache in that direction? And older processors were not so good at that, but newer ones are fine at it, to my understanding. Although, again, you never know till you profile. But basically, this is not something I would worry about on any processor from like at least the last 10 years, if not earlier. Like, I'm pretty sure they're good at strided accesses and all that stuff, right? Like, so if you went like 1K at a time forward in memory, I think it would notice that these days. But I'm not sure about it. I'm less sure about that than I am about forward backward. Mike actinizes things automatically. It's not that easy. If I knew how to do that, I would do it, but it's not that easy. All right, it's past 11 p.m. Thanks, everybody. I'm going to go to bed. We will probably resume in the morning, and we will do something involving graphics and drawing these file results that we have. So see you later, everybody.